This was the last question, like constructs the character table, C2A is character table. So that I'm not going to discuss. But this one, let's discuss it. I think you guys had a lot of complaint about this question, right? I don't know what was the how people are joining. Yeah, so this one, assuming the molecular plane, that is XY, right? That is in the XY plane, and schematically sketch the shape of this P pi PZ and pi star PZ, right? Okay, so I think you have already done this. Like if you are taking this is like XY plane, I'm just like this, then Z is going to be along this, right? So if I am having PZ on one nitrogen, right? That is plus, and this is minus. So that is first nitrogen, right? Similarly, I'm going to have second nitrogen, right? So that is plus, and this is minus. So this is another nitrogen. Okay. So now, so this is pi PZ is going to be the plus combination. Right? Now, if I do plus combination, then the resultant what I get, this plus plus will remain plus, so they will make a lobe like this, and this minus minus they will make a another lobe. So it's going to be exactly symmetric like that. So that is resultant is going to be, this is going to be plus, this is going to be minus. Right? I hope this much you have learned in BSc. Right? Even if you have not done this, Rokshit might have already discussed this in LCM approach. Like if you're taking two s orbital for H2, one is A, one is B, then you just do the combination. So that is the plus combination. So that is pi PZ. Right. Now, if you are going to go for the minus combination, so again I go this is a minus combination. This is plus, right? This is minus, and it was plus, but if I go for minus combination, so that means I'm taking minus. So let me draw initially whatever it is. This is plus, right? Now I'm going to take the minus combination instead of plus. So there it was plus combination, now I'm taking minus combination. When you do this minus combination, so this becomes minus, and this becomes plus, right? So if I now do the combination, the resultant I would get, so there will not be a positive overlap. So instead of that, I'm going to get a something like this, and then this is going to be this. This is going to be like that, and this is going to be like that, right? So this part is resultant, this part is going to be plus, right? This is going to be minus, right? Again, this is going to be minus, and this is going to be plus, right? So this is kind of a d orbital. So that is basically your pz star. Right. So that is the first case, the shape of this. If you have done this, I mean, like, of course this is in 2 dimension, but that is the kind of shape we are expecting. Right. Now last part was the find out the irreducible representations, what they belong to. It's like you have to do the operation for N2 F2 molecular point group. So that is C2H, right? Now for C2H, so what are the operations I am going to have? Now operations I am going to have identity C2, then you are going to have sigma H and inversion. Right. So if you operate this on this, what do you get? Identity 1. If you are doing C2 along Z, this is P pi Z, so it will go, Z will go along this, so that is also going to be 1. Sigma H, sigma H is the molecular plane, right? Now that is going to be perpendicular to this, Z axis, so that is going to be XY, right? If it is going to be XY, so that means plane is going to be like this in the middle, so this is going to change the sign, so that is going to be -1. Now inversion, if you do, right, inversion center is here, right? So inversion, if you do, inversion center is sitting here because nitrogen here, inversion is center is here. Now if you do the inversion, if I go from one side to the other side, invert it, so that is also going to be -1, right? So what is going to be the irreducible representation then? So this is 1 dimension, so that is going to be A or B, right? Now it is symmetric with respect to principal axis, so that is going to be A, right? And then when we have, as I said, when we have inversion and sigma H, right? So this inversion gets preference, so this is going to be inverted, right? So that is going to be ungerade U, right? So that is this one. Now if I go for this one, you get identity same, no problem. I am doing C2 along this, right? That is Z. So therefore it changes sign, right? So that is why it's going to be -1 sigma H. So that is this plane, right? Again, it's going to change the sign. So that is going to be -1. Now inversion point is here. If I do invert, that is going to be +1, right? So what is going to be its irreducible representation? So that is 1 dimension. It's going to be either A or B, but this is minus, so that is going to be B. Right? So therefore, this is going to be B, and again inversion gets preference. So if you get this, that is plus, so therefore this is going to be Gerardi. Right? So now to make sure that if you have done it correctly, you can think about like this. Z is along this, right? Now this is definitely going to be something like more like a PZ, if you are thinking about, except that it's like a deformed form, right? So how PZ is going to transform in C2H, you can easily figure it out. That is going to be AU. Z is again ungerade, and Z remains unchanged like this. goes along Z. So this orbital goes along Z. So if you can think about PZ orbital, right? So that is, if you look at the character table, you will go along AU. Now this one is, of course, you have to go for a D orbital because it's going to be kind of binary function, right? So this is kind of like if you are taking this is Y and this is Z, so you can think about DYZ, something like that, and that is going to be some. This is BC, right? So I think that's what is the expectation. I don't know how many. Some of you have already done it. So rather than that,